Let's solve question 5.8.2. So we got question 5.8.2. It's about bonds. So we have a bond that has a value of 10,000 pounds. So let's call it actually 10,000 euros because it's more comfortable. 10,000 euros. And the interest rate on that bond, so the rate is 9%. The rate is 9% and the lifetime is 10 years. This is the data, and let's solve with this data. Now, before we go further, let's actually make sure we understand what is a bond, because we say we buy a bond. So if we buy a bond, it means we're paying money. How can we pay money? Where do we pay it? We pay money. Well, we pay money because we lend money. This is lending money. And when we lend money, what do we expect? Well, we expect a return. We expect the money to come back. What we are expecting is to get our money back. We want money back and we want interest rate. Money back plus interest. Okay, so buying a bond means lending money to someone. So we're lending money. How much do we expect to get back? We want our principal or we want our interest rate. We call this coupons. So the interest rate on the bond is called coupon. Okay, it's getting better. How much is this coupon? Well, it's 9%. 9% of what? 9% of 10,000 euros. Well, let's calculate. What is 9% of 10,000 euros? Well, 9% of 10,000 euros, 10,000 euros is equal to 900 euros. So this is the interest that we're getting on the bond per year. That is per year. How many years? Well, we have 10 years. So we're getting 900 euros in interest for 10 years. But remember, this is 10 years from now. So 10 years in the future we'll be getting this amount of money. Whenever we make a decision of money, we have to see what is the money worth now. So we want to know the value of the money now. What is the value of money now? We call it the present value. This is our present value. And how can we calculate the present value? Well, the present value means that we have to discount our coupon, our interest on the bond, at a different market rate, whatever the market rate is. And in our question we have 3 cases. So let's solve those 3 cases on the table that we have. Let's go to the table over here. I printed it over here. Yeah, here it is. Let's actually understand what's happening here. You see, we have 10 years, we have cash flows and different interest rates. So this is the cash flow that we're talking about. This is the cash flow that we're talking about. This is our coupon, what we just said. This is our 900 euros. And these are the three cases for the interest rates. You see, depending on what interest we discount, we will have different present values. So this is just, what is 845.07? That's just 900, the coupon, divided by 1.065 to the power of 1, because we discount it for 1 year only, because we're looking at the year 1. And that's equal to 845.07. Let's take a random other value just to prove the logic. What is 510.68? Well, that's the value of the coupon, 900 euros, discounted at what market rate? At 0.12, so 1 plus 0.12, it's 1.12. To which power? Well, it's after 5 years, so we're discounting for 5 years. And that's equal to 510.68. Why do we do all these things? To calculate the present value. The present value of our coupons, because remember, the 900 euros, that's in the future. That's 1 year from now, 2 years from now, 3 years from now, and so on. But in today's money, we want to know what is the value to realize if it's worth buying the bond. So we're doing all this math and we're adding up all these numbers, and we get to 6,469, and then 5,775, and then 5,085. Why does this value decrease? This value is decreasing, then this value is decreasing again, because we're discounting at higher and higher interest rates. It makes sense. If we are discounting at 6.5%, we get a higher number than when we discount at 12%. And why is that? Because whenever we divide a number a number divided by a small number, we have a higher value. Our number as a result goes up. But if we divide the same number by something bigger, so instead of dividing by, let's say as an example here we had 6.5% initially, that's our small value. But if we discount at 12% at a higher value, well, the result goes down. The result goes down. And that's actually what's proven here. Our value of all the coupons is going down as our interest rates goes up. Now, that's just the coupons. Remember, we also have to get our 10,000 euros back. But the 10,000 euros, we get it in 10 years from now. So what is the value of the 10,000 euros today? Well, we have to discount the 10,000 euros by 10 years. And how do we do it? With the same logic. We take the 10,000 euros and we discount it at different market rates. So in this case, in case 1, we discount it at 1.065 at 6.5% for 10 years. And that's equal to 5,327.3. And then we're discounting it. We're discounting it at the other interest rate at 1.09, so at 9% for 10 years. And that's equal to 4,225.1. And in the third case, we're discounting it at 12%. And again, notice that the value, the present value of our principal, that's called the principal amount, the money that we actually lend, well, it decreases in present value because we're discounting at higher and higher values. And here we have 3,219.7. Now look, these are the values of the principals. What do we have to add to each of them? We have to add the values of our coupons. These are the present values of our coupons. This is for the 6.5%. So we add the value of the coupons discounted at 6.5%. And the result is equal to 11,797.2. Now, the 5,000 belongs to 9%, so we're adding it over here. We're adding 5,775.9, and as a result we have 10,000 euros, exactly the amount that we lent. And here we are adding 5,085 when we discount at 12%. Let's estimate to 2. And the result is 8,304.9. So this is the present value of the bond. This is how much the money is worth today, including the cash flows from the coupons. And the question is, do we buy the bond? Do we lend the money or not? Well, we lend 10,000 euros, so we have 10,000 euros today to lend. The money that we get back in today's terms, in today's value, are given here. It's what we calculated, and we can see that 11,797 is greater than 10,000. So that's good. That's a profit for us. 10,000 equals to 10,000. So here we just break even. But then 8,000 is less than 10,000, so we're actually having a present value of the bond and the coupons that we're getting, which is less than the amount we're lending, so that's not profitable for us. So we would go for this case. When we have to discount at a lower interest rate, so in this case at 6.5%, is more advantageous for us, then we have to discount at 9% or at 12%. I hope this makes sense. We are done.